Flack math! Give me some math and I'll give you some flack. Flack math!
Okay, lesson 32. We're going to solve linear equations. Solve linear systems with matrix inverses. Okay, matrix inverses. So what's the inverse of 5?
1 over 5.
1 over 5. If you're talking about the multiplicative inverse, whatever you multiply by 5 to get 1 is the inverse, the multiplicative, and that's what I am talking about. Okay, so remember and that's the identity. So the identity matrix, like a 2 by 2 identity matrix, looks like this, remember? We talked about that a while back, but that's the identity matrix. So whatever you multiply by a matrix to get this as the answer is the inverse of that matrix. Okay? So let's just officially review that. So if I were to multiply these, so here's just a really quick warm up. AB, if A equals -2, 0, 5, 1, and B equals -0.5, 0, 2.5, 1. If I multiplied this together, AB would be, let's see if we can do this in our head, -2 times -0.5, so that's +1 plus 0 times 2.5, so that's just +1. So that 0 is nice because that's only one multiple. So now I'm taking this and multiplying by this column. So -2 times 0 plus 0 times 1, so that's just 0 there. And then 5. Now we're going to do this row times these columns. 5 times -0.5, so that's -half of 5, so that's -2.5 plus 1 times 1, so -2.5, time plus 0, sorry. So -2.5. I'm doing it wrong. Oh, that's annoying. So 5 times -0.5 is -2.5. Oh, sorry. Times +2.5 is 0. 5 times 0 is 0. 1 times 1 is 1. So we ended up with the identity matrix. So that means this must be the multiplicative inverse of this. Well, look at it. Look at it. Let's analyze it. So this is -2. This is -1/2. This is 0. This is 0. This is 5. This is 2.5. This is 1. This is 1. So what's happening? Well, this looks like I just flipped it. So -2 flipped over would be -1/2. Okay? But this is not a flip. 5 over 1, 2.5 is not 1 over 5. But it looks like half of that. Okay. So here's the deal. You don't really have to analyze it, but it's interesting to see what happens. If you flip 1, you get 1. So that makes sense there. So let's see how to find the multiplicative inverse of a square matrix. Okay? Let me just make sure I'm telling you correctly here. Now this works, but it only works if it's commutative. So if I multiply b times a, then I would still get the same thing. So BA would be -5 times this column, so it still get negative or positive 1 plus half of that. So let's see here, plus 0, so positive 1 there. Multiply -5, negative 0.5 and 0 with 0 and 1, so I get 0 and 0. Okay, and then I do multiply this row times these columns. So -2 times 2.5 is like, what is that? -5 plus 1 times 5 is 5, so -5 plus 5 is 0. And then 2.5 times 0, 1 times 1 is 1, so you still get that. So these are inverses because AB equals the identity matrix, but sometimes AB will equal the identity matrix and it's not the inverse. But the reverse has to be true as well. BA has to equal the identity matrix.
Trick or treat.
Oh, thank
It's a
you.
white chocolate Kit Kat. of
I
some
know, I
sort.
saw that.
Thought of you.
Thank you. You're a good brother. Love you.
Mr. Flack, may I use the bathroom?
Yes.
Thank you.
Okay, so
Okay, Mr. Flack, can I teach your math class? Because according to Drew, if I teach the math class, I get a Kit Kat.
oh wow, that's not gonna happen. Okay, so to determine whether something is an inverse matrix, you have to be able to multiply to get this answer, but you have to be able to reverse the multiplication to get that same answer. Okay, to get the identity matrix. Now let's skip through that, and I'm going to tell you how to find the inverse matrix, which is complicated. Okay, it's just the formula, which you are free to use on tests to come and in your homework, but this is the formula. So in a 2x2 matrix, if A equals A, B, C, D, then A to the -1, this is shorthand for the inverse matrix, because really what's happening, anything to the -1 power, you're flipping it over, right? So A to the -1 equals, and here's the annoying part, 1 over the determinant of A (1 over the determinant of A times this matrix.
Oh, wow. Oh.
D, -B, -C, and A. Okay?
No, it doesn't.
All right.
Do you think
So,
that makes sense? Something's
these are with letters, and letters are kind of confusing. So let's just try to apply this to an example. So I'm going to find the inverse. This is example 2A. Find the inverse of T, which is 3, 4, -1, and 2. So what does T to the -1 look like? Okay, so what do? Let's plug it into here. What's 1 over, okay, how do you find the determinant of T?
No. You do the upside down fish method? Yeah, right? I'm pretty sure. Yeah. It's like 3 times 2 minus -1 times 4.
Yep, 3 times 6 minus -4, which is +10. Okay, so this is 1/10 times this matrix, which is 2, -4, 1, and 3. Where the heck did I get those answers, those numbers? So all I did was put A down here, and I put D up there. So I just swapped these two numbers, 2 and 3, so now it's 3 and 2. Okay, and then I didn't swap these numbers, but I just negated them. Okay, so you swap these numbers, but you negate these numbers. So if the numbers were 4 and -1, it's -4 and +1. Okay, so there's swapping, there's negating, there's craziness happening. Okay, but at the end of the day, it's just a formula that you need to memorize, which you don't need to memorize, because I'm going to let you use it. Okay, you won't be asked to find something like this on any kind of placement test without they'll give you the formula for that. Okay. All right, well, let's just do this. Let's just distribute that 1/10 to everything, and we'll be done. What's 1/10 of 2? 2/10, or 0.2. Just divide everything by 10. Just move the decimal over one place.
No one know. So burnt out.
So -0.4,
Oh my god.
0.1, and 0.3, and you're done.
Wow. God. He was like, you are going to notice. I'm like, no.
Okay, so the hardest part is the determinant, I guess. But since you don't have to remember this, just switch these, and then you're going to negate these. That's all you're doing, okay? And that's what you're multiplying by. But you still have to find the determinant, and that's what you're dividing everything by inside the matrix, okay? Okay, so all this leads to this kind of example.
Oh my god.
So when I do something like this, 3/4 x equals 15. How do you solve for x?
You like get rid of the.
Yeah, how do you get rid of the 3/4?
Divide.
You divide by 3/4, which is the same thing as multiplying by 4/3, right? So I just need to multiply both sides by the multiplicative inverse. Okay, and I get 20. That's what we're going to do in this next example, the final example.
Then you're gonna be like, take a nap.
Not the final example, I'm sorry.
Oh, I like that.
But the nap.
That's good.
That the nap. I'm just gonna skip my next class and take a nap. So tired.
Last time I did that, I
Okay, so here's the next example. Solve
You're not wrong,
had
but my next class
11
is
tardies.
for matrix
That's a fun class.
X.
Yeah.
Here's what it is.
Yeah.
12, 7, 5, 3 times matrix X equals 2, -1, 3, and 2. So how do you solve for X?
Oh, I see.
You multiply by the inverse of that.
Yeah.
So let's find the inverse of that.
Okay, I see. I didn't expect that to make sense.
Okay, so the inverse. Remember, we're going to swap these and negate those. So here's what the inverse looks like. So 3 and 12, -7, -5. So far, so good. But we're dividing by, so 1 over the determinant of this, which is 36 minus 35. That's nice. That's 1, so you don't have to worry about that at all. So this is what you're doing, multiplying by both sides, okay? So multiply the same thing, whatever you do to one side, do to the other. And then we're done, because these will cancel, and you're left with matrix X equals, let's do this multiplication. 2 times 3 is 6, plus 5 is 11. 2 times -7 is -14, plus -12 is -26. 3 times 3 is 9, plus -10 is -1. 3 times 7 is -21, plus 24 is 3. which is not what they got. So what did I do wrong? 12,
I'm
7.
gonna find it.
Mr. Flack, that's wrong.
Yeah.
Free problem set?
If
Yeah.
you can tell me why it's wrong, then that's gonna be awesome.
Because the book
Six.
says so.
We're gonna
try
try
so
this.
Kira says so.
Yeah.
You should give Kira a free problem set. Oh, there's really something stuck in my throat.
Yeah, you
Was
should.
it-
I feel like you need
Is it an
to. You need to actually. You need to reward your students for paying attention.
You do. We were all paying attention.
And plus, we're really tired today, and we're still paying
Everyone seems
attention.
so tired today.
I got
You're
I
not
got
paying
3
attention,
hours
though?
of sleep
Yes.
last night.
Ask what a 10th of 2 is.
Last night, so.
And none of us could
Beating you
answer.
by half an hour.
Or I'm meeting you in
Okay.
half an hour.
6.
This is true.
I
Give
mean,
Nathaniel
I got from work
free
and I
problems.
saw so much Oh, full.
awful.
Oh, you know what I'm doing?
Why
I'm doing it backwards.
Why do you
Okay.
flip the next? The X. Actually, never mind.
So here's what I did wrong. Matrix multiplication is not commutative. So I have to multiply this by this, not this by this.
Why?
Okay?
What?
That makes it so much harder.
I
Why is
know.
multiplication not commutative?
I know.
Wait, what?
I'm sorry.
It's same. I don't know. They're all like, no, and I'm like, what's that?
Wait, so what tells you what order they should be? How do you know?
Holy
Oh my God, Mr. Flack, you're killing me.
I know. I'm sorry. So you're
I'm
multiplying
really
this.
confused why there's like a -1 that like has a cross, the 1/1 that's crossed out.
Because
What
because
happened
of
there?
the formula down there with the determinant
Oh,
of
the
the
determinant.
of the matrix,
You
but the
don't-
matrix determinant is 1, and 1/1 equals 1. So.
Okay, so you get 6 plus -21, which is -15. And then you get -3 plus -14 is -17. Then you get -10 plus 36 is 26. 5 plus 24 is 29. Okay.
How do you know to put the matrices in that order? Because that matrix wasn't on that side of the equation before.
But you
now-
multiplied this by this to get rid of it. So you're going to multiply this by this. So you're doing the same thing in the same order.
You could have multiplied.
You could have. Yeah, and here's the deal.
Okay.
You could do it that way. If you multiply it by this, well, I mean, you could check it, but then you would have had, no, that wouldn't have worked.
Just be happy that you.
So if you cancel a matrix, it goes on the left side.
Well, you're
Goes
you're
first on the
just
other
multiply
side of the
by the
equation.
same order you did that in.
I feel. Could I not have done it in the opposite order on the left side of the equation?
Well, on the left side, it doesn't matter what order you do that in. You should get the same. You should get the identity matrix. So if
Yeah,
you do,
But then, so then.
So it is commutative.
So the other one doesn't matter. The first one doesn't.
So no, yeah. What you're saying is, so you're saying
It's commutative over there, but it's
No.
not. It just
yeah, this is
stops with-
commutative because these are inverse matrices.
Okay.
Yeah.
So inverse
Right.
matrices are commutative when you multiply.
So you're
Right.
saying you have
So
to.
there's no order
so
there.
You have to.
But
Right.
suddenly there's an arbitrary.
You
order
have
on
to
the
put
right
the
side of
inverse
equation.
matrix on the left of that
Yeah.
matrix.
So just
Alright.
remember
Ugh.
that
It's
it is
50-50
not
chance.
I'm gonna mess this
it is not commutative.
It's fine.
Okay.
Oh my god.
These would.
Science that.
Talk a lot about the election. I don't want to talk a lot about the election.
I don't want to talk so much about the election.
That's all I hear at home. I'm done.
Oh my gosh, me too.
Especially with my dad. I'm like, shut up.
Wait, you're 18?
I am. I voted.
Wow.
You're
I don't know.
I wonder who I voted for. Wow.
I
really
definitely really
Kanye.
don't know you.
Kanye.
I wrote in Nathaniel.
Okay, guys.
Nathaniel President 2020.
I love
Yeah, Nathaniel 2020.
Kanye West.
Oh.
He's so disrespectful.
So funny. Yeah, he's a little. Jacob didn't even vote. He was like, I'm not voting.
I think a lot of people.
Fair enough.
We have two.
Okay, guys, all this leads to the whole point of this lesson,
I was like, for once.
which is solving a linear system using an inverse matrix. So if you have a system like this, you have, and we don't have to do this together, and you don't even have to solve your invert like this, but you can make a matrix. So your matrix looks like this: 3, 2, 1, 1, -1, -3, -1, 1, 4.
That sounds great.
Yeah, why does
Yeah,
it
no, I love cash food.
It's the cooking class.
in the history room, we can smell the most.
I wish that I was meant.
Your mouth smells like
Dude, I get
cookies.
some new cookies.
There's literally like 2 lunches.
So you can solve for this by using an inverse matrix. Hey guys, you can be done, but I'm not done. So you need to at least be respectful.
Sorry.
Okay, so write the system as a matrix equation. This is basically what I did. So here's all the coefficients. And then to solve for that, you just multiply by the inverse.
We're solving for X, Y, and Z.
X, Y, and Z. And this can all happen with one, instead of trying to do this in a confusing way, trying to use elimination or substitution, you can do that using matrices. And we're out of time, so unfortunately, you can't. If you wanted to look at it, you can, but
So we should just do probably like problem set. If we're gonna do a problem set the full Thursday, probably just do problem set.
I mean, you can still solve these problems. You just don't know how to do it with matrices yet. But we can go over that a little bit later. But you won't have a test on this anyway, on that specific problem. You will have a test on this guy. So we will review that before we take that test and make sure you get the right order and doing it the right way, okay?